Allow me to introduce our speaker for the evening, the hierarch of hexagonal, the oligarch of the onion, the star of the CQRS, Herberto Graça.
Thank you. This is recorded, right? This is awesome, man.
You can make this your new answering machine message.
Yeah, something like that. Okay, so yeah, let's start this. If this works, no, wait, I have to turn it on. Okay, so first, who am I? So I'm Portuguese. I moved to the Netherlands about 7 years ago. Still don't speak Dutch, unfortunately. Sorry about that. I used to be a high school teacher. I was teaching IT, then I got fed up with the crisis in Portugal and everything, and just quitted my job and came to the Netherlands and started being a full-time software developer. I'm currently senior developer at Werkspot. I don't know if you guys heard about it. It's like a marketplace for home improvement services. Like if you need a plumber, you go there to the website, say I need a plumber to fix whatever. And then there's plumbers applying for the job, and you choose a plumber that you want. Yeah, and I have a really cool motorbike, as you can see, that I love. And it's parked away because it's never good weather to ride it, except now. And now I don't have a battery anymore because I didn't charge it in the winter. So yeah, so let's start. So what's this talk about? It's well, it's about ideas that are from people smarter and more experienced than me. So mostly about that. Oh, it's okay. And it's about my own mental map of how I put all those ideas together to actually take profit of those things when I'm coding and when I'm discussing ideas with my colleagues at work. What this talk is not about is one boot fits all. There's no silver bullet and there's no holy grail. So the idea is that we learn as many ideas as possible and then try to figure out what actually works for our project and for our team. I think history is very important for all of us. I think we have our own personal history. We grow up and we at least I do mistakes all the time, but then I try to not make those mistakes very often. As a community, we do the same. As a country, we learn history in the school, and one of the reasons is exactly so that we learn from mistakes of the past and don't do them again. And as a developer community, we should do the same. That's why we should read books and watch talks from people more experienced than us and try to learn from it as much as possible. Keep the knowledge coming back. So I'd like to review a bit of history of ideas, architectural ideas that came up in the last few years. So we started around in the 50s with non-structured programming. We had just some assembly code. We were coding some small programs, and then we started making things bigger and bigger and bigger. And what we did then is find some way of creating some loops and conditionals so that we could avoid repeating code that much. Then we moved on because it kept on growing. So we moved on and we started doing procedures and functions so that we could again not repeat so much code. And then eventually we arrived to object-oriented programming, which actually puts data and the logic that is associated with that data together. And around the 90s, we couldn't really evolve the language paradigm anymore. It didn't evolve anymore. So we had to move on to design patterns. So it's a bit of a higher level abstraction, granularity. But it's about putting classes and objects together in a specific way to solve common problems. And if we think about it, this is all derived because we have a problem that keeps on growing, a code base that keeps on growing. And what we do is we break it up in smaller pieces and then try to organize them and fit them together, right? Now this is not a software engineering principle. This is an engineering principle. You see it everywhere, engines, buildings. So This is pretty common. And then parallel to this, we had also an evolution in architecture. We started with the monolith, and then we have Corba, which was in the beginning of the 80s, the first attempt at distributed computing. And Corba worked in a way that abstracted completely the fact that there was a remote server running code, and we connected to it. And that was nice, except that it was not so nice because we were making a method call, and we never knew, in fact, if it would run locally or in some remote server. So there was a time gap there. We never know if it was going to be instant result or if the code would have to wait for a remote call. So then we make it a bit more explicit, and we create these services. So we have service-oriented architecture, we have web services, and in our code, we create code that specifically calls those web services. And then, at that point, we had web services, but they were speaking different languages. They had different inputs and different outputs data structures. So we needed something in between to actually translate between web services. And it's some kind of a middleware. And that was the idea of the enterprise service bus. And this was, it sounds like a really cool idea. It was, to a certain extent. But then, there's this really cool thing in the middle, and it's the perfect spot to put some domain logic. And it keeps on growing and growing with domain logic and domain logic. And at some point, no one dares touch it, because if that piece in the middle breaks, then everything around it breaks because they cannot communicate anymore. So then it's a big problem. So then we move on to microservices. In microservices, you have actually one principle, which is smart endpoints and dumb pipes, which is exactly about this. Not have any smarts in the middle between the microservices. And now we are already talking about nanoservices and so on. So in the end, in both cases, it's about a problem that is growing, a code base that is growing, and we're breaking up that big piece of code in smaller pieces and trying to fit them together. And this is, in the end, about modularity and encapsulation. It's about having pieces that we can take out and put in as we wish, and about putting code that is related together, grouping the concepts, and hiding away the details. So let's talk about the monolith now. A few years ago, when the microservices were the hype, we were all saying that the microservice will solve all problems, and we had a big ball of mud, and the microservices would solve it. But that's not, nowadays we know that it's not quite like that. We now know that if we cannot manage a monolith, we won't be able to manage if we don't manage a monolith, we won't be able to manage microservices. In my view, there's 3 reasons to go to microservices. Polyglot systems, so systems built in different programming languages. If we want independent deployability or independent scalability. Otherwise, I think the monolith will probably do the job. But anyway, how do we get to a big ball of mud? I mean, we have a monolith that doesn't necessarily mean a big ball of mud. So when do we have a big ball of mud? Well, there's some examples. For example, when a class and a method, they don't convey the meaning. So we need to dig into the code to actually understand what that code is going to do, what that method, what that class is about. Also, when we don't have an obvious place to put the code. I remember one colleague of mine in a company where I worked. When I arrived there, I did some code, and then I went to him, and I did this. It's working. It's great, of course. But now where do I put this? And he told me, just put it everywhere. It's fine. Just make a folder there. And this is not how it should be. There should be a specific place for a piece of code. It's also when you have a dependency mess. If we have dependencies on dependencies on dependencies and we don't have control over it, at some point we touch something on one side of the application and break something on the other side of the application. And also when we cannot test it and we cannot refactor it. And this is, for me, quite important because refactoring works in a way that you change the code without changing its behavior. And you know that you're not changing its behavior because you have tests. Now, when we do tests, we should not focus on methods and on testing methods, and we should not focus on testing classes. We should focus on testing the public APIs of modules. And a module might be one class, but it should be, what we should focus on is the module. Why? Because, well, imagine if you're testing a class, you have private methods in the class, you're not going to test the private methods. They're in implementation detail. If you have a module with 10 classes inside, and only one of them has the API for that module, what are the other 9 classes? They're in implementation detail. So why should we test them? At any point, we might change the implementation of a module. We should not have the need to change the tests. The problem is, if we don't have boundaries for the modules, how can we do this? So we need to have the boundaries for the modules. Anyway, this all happens in the end because we don't have a clear and enforced way to design our code base. So how do we solve it? We have a big ball of mud. This is a big ball of mud. If you have this at home and we need to take some nuts and bolts to do something in somewhere else, then yeah, we're going to be quite some while trying to figure out where we have the nuts and bolts that we need. And if we need to work with this every day, and we need to take this to work, yeah, it's all a mess. When we get to work, we need to, again, try to find the nuts and bolts that we need. And if we only need half of them, you can take only half. You need to take them all. So how do we solve this? Well, we organize it, right? You find the bolts that are similar. You put it in a little box, and then you group the boxes. And then you put them all in a bigger box, and then you can put it in the van and take it home, take it to work. Well, with code, we can do the same. So how does it work then? We have granularity levels as well. So we have the plain code, then we have methods, then we have classes, then we have namespaces, which are folders. And then finally, we have libraries. And I think most of us, we already know about clean code and about solid principles and so on. But when it comes to namespaces, that's still a bit of a problem, I think, in the community. So I'm going to focus on that now. So in the end of the 90s, there was, so Uncle Bob published a series of articles, ideas, principles in an online magazine. He didn't come up with all those principles himself, but he published them there. And I think he became famous because of that. And I'm recalling 3 of them here. So the first one, the single responsibility principle. He sees it as a class should have only one reason to change. I see it a bit differently. I think more as a code unit should have one single responsibility. And it's an important difference because, well, a method should also have only one focus, right? Only one responsibility. And the classes as well. But the modules as well. If we think about an ORM, there's only one responsibility to the ORM. Translate from objects to a database, to a relational database. It's only one responsibility. It does a lot of stuff in the middle, and you can go into it and see all the stuff that it does, but in the end, there is one responsibility to that module. Then you have the common closure principle and the common reuse principle, which means that code, that classes that work together should be packaged together, should be living together. How many here are PHP developers? Okay, so Symfony, for example, and I bet many more frameworks from other languages. What Symfony does is creates, by default, creates a source folder for you, and then creates a folder for your controllers. And then next to the folder for the controllers, creates a folder for resources, and inside that one, a folder for the views, which are actually templates. Now, this ends up in you having one folder structure for your controllers and another folder structure for your templates. And then you're going to try to keep them in sync so that you know which templates work with your controllers. And then you end up never managing to do that. And every time you are searching for templates that are used in one controller, you have to go and search another folder structure, and it's a bit messy. So what he says is this should not happen. If you have one controller, you have 2 or 3 templates that work with that controller, put them together. Put it together in the same folder, then you know exactly what's working with what. Templates, in this case, I think they're not really reusable anyway. I think partials are reusable, but templates are not. So it's the 90s, and we have layered architecture, N-tier architecture. We had first 1-tier, then 2-tier, then N-tier architecture. Then we can see here the dependencies were going downwards. Top layers know about the bottom layers. Bottom layers don't know about the top layers. In this case, the business logic knows about the data layer, which comes to mind as what's the name of the pattern?
Field controller?
No, sorry. The active record. Active record, because in active record, the entities actually know about the database. Okay, then 2003, domain-driven design came along. Eric Evans publishes his book. I'm not going to talk about domain-driven design extensively. It would take a long time. But I can talk about what's important for this talk. And domain-driven design, it all starts with domain-expert interaction. The developers should be together with the people that should be able to talk with the people that use the software, that need the software, to figure out what the software is about, what the users actually need. Now, this can be the users or ideally the user, but some representative of the users as well, the product owners, the business people, so forth, so on. Now, these days, EventStorm is very popular for that. So there's this domain expert interaction. People talk to each other, and we create this ubiquitous language. This ubiquitous language is a set of terminology that we will use to communicate with people, but also in the code base. Okay, so we have all this knowledge, and then we need to sketch it out to discuss about it, and we can create a context map. And in that context map, we can create what they call bounded contexts. And bounded contexts are isolated pieces of your code base. So for example, in this case, you have bounded context for products, bounded context for categories, for the CRM, for the orders, so on. Then there's a piece of code, usually at some point, that you need to share between bounded contexts for some reason. And that piece of code, we'll call it the shared kernel. So for example, we have events or whatever else, and you need to share that, of course. Then that's part of the shared kernel. You also have code that is anti-corruption layer. And this is, you can see it as a translation layer between bounded contexts so that they don't know directly about each other, so that there's no leakage of code from one bounded context to another bounded context. So these are the few concepts that I want to take out from DDD. So then there's 2005, and Alistair Coburn, he publishes a blog post in his blog about hexagonal architecture. And he later on changed the name into ports and adapters. And he talks mainly about how to connect the application with external tools and delivery mechanisms. So one side you have delivery mechanisms. There we have, for example, a website. We have HTTP, HTML, that's a delivery mechanism. We have an API, that's another delivery mechanism. And we have all these delivery mechanisms. We want to execute the same use case in your application. For example, creating a user. If you don't want to duplicate that code, right? You want to use that code always, the same code to create a user. So how do we do this? We create an adapter. So we create an adapter. That adapter will receive a piece of data from the delivery mechanism. For example, if it's a website, we receive a request. Then what we do is that you take data out of the request, we extract that data, you pass it on to the service that actually executes the use case. If it's coming from an API, you do pretty much the same. It's a controller. Probably the data is structured differently inside the request, But yeah, you take out the data and you pass it on to the service that actually creates the user. Same thing for console commands. This he calls the driver adapters because they drive the application. They tell the application what to do. On the other side, we do the same, except that on the other side, the port is slightly different. While on the driver side, the port is a use case, a service with some code there. On the other side, you can see it in this most simple form. You can see it as an interface. So then what your adapter is going to do is wrap around an external tool, a library, for example, and implement that interface. That way, we can use that adapter inside our code base, and the code base doesn't know about it. It knows about the interface, but it doesn't know about the adapter. If we need to switch the actual library that we use, we just need to create a new adapter, inject it inside in the interface, and that's it. We're done. These are called the driven adapters because they are driven by the application. The application tells them what to do. So then it's ports adapter still. Here's an example of a driver adapter. So it's a controller. Let's suppose a login controller. He gets injected a service that actually has the use case to log in. And there's an action called login that receives a request. We get the data out of the request, and we pass it on to the service, to one of the methods of the service. On the other side, it's similar, but slightly different. We actually get injected the external library. We implement an interface that belongs to the core. And then we have a method that is used in the core. It's defined in the interface, used in the core, receives some data, and transforms it into whatever the library needs. So then, 2008, and there's Jeffrey Palermo. I think he was working at Microsoft back then. He publishes a blog post where he talks about what's inside of the application. So before it was about the application communicating to the outside, he talks about what's inside of the core of the application. So he identifies 3 layers. First one, the domain layer, where you have the entities. So basically your domain, your business objects with your business rules, and the data that they are associated with. And also, of course, the objects, the data objects that they use, the value objects, the enum, so forth, so on. Outside of that, there's the domain services. There are the service classes. They have domain logic, but the domain logic doesn't quite belong in one entity. So it's mostly about coordinating entities. And then finally, the application services, which actually contain use case logic. Typically, you have a use case. It's a class, a service class, receives a repository, tells the repository, give me some entities, tells the entities what to do, add 3 + 1, whatever, save this data inside yourself, and then persist the entities into the database. That way, the actual entities don't know anything about the database. The database knowledge is in the repository, which is part of the application services. So then it's 2011. And then it comes Uncle Bob again. And he comes to say that we are organizing our code base in the wrong way. Because we have a folder for all controllers, a folder for all views, and so forth, so on. And he says, OK, the first thing we should see in a code base is actually the main concepts of the application. So if the application talks about healthcare, create a component for that healthcare. If there's about accounting, about billing, then create components for that and separate them. And if you think about it, relative to microservice, that's pretty much what microservices do. They pick up one subject of your application and put it in its own place, its own server. Then there's Greg Young, and he became famous because he started talking about CQRS. And how does this work? So you have a presentation layer, you have a controller, and instead of the controller calling a service to execute a use case, he creates a command. And the command is just a DTO, just a glorified array. And he creates a DTO and sends it into a command bus. dispatches the command. And in the command bus, it goes through several steps. For example, first it validates the data that is inside the command. Is it actually valid for what we want to do with this command? If it's not, it responds with an error immediately. Next step, opens up a database transaction. Okay? And then it handles the command. By handling the command, what we mean is it delivers the command into a handler, into a service that, well, has all the data in one object, does its use case, gets some entities, persists them, whatever. And then, when it's done, returns control into the command bus. Then we close the transaction, we commit, and the data is persisted finally. Now, this in itself is not very different from what we usually do of calling a service in a controller. The interesting thing is that we can also enqueue it. So we can queue the command. It's just a bunch of data. We can serialize it, put it in a queue, RabbitMQ or whatever, and then it sits there. And it sits there until some worker picks it up from the queue. So you can have several workers just working in parallel, taking one command at a time, one serialized command at a time from the queue, and then delivering them into a handler. Handler handles it, so forth, so on. Transaction is closed, it's done. And this is interesting because you can parallelize the workload. If you need to send out emails, it's the most generic example. If you need to send out an email, the user doesn't need to wait for the email to actually go out. You can immediately reply, OK, we're going to do this for you. And in the end, the email is sent at some point. So this is what they call the write model. So this is used for when we want to do something that changes the data of the application. And then when we want to just read the data because we want to show it, we can do it differently. Because in this side, to write, you need to iterate entities and so on. There's a lot of business logic of things that need to happen there. But when you want just to show data to the user, you don't really need to do much. So you can just issue a query and get the data, put it in the screen. OK, so recap. How do we think about all this? OK, so we have the user interface on one side, the infrastructure on the other side, application core in the middle. On this side, we have users sending requests into our application. On the other side, we have libraries and tools. The requests reach the first adapters. So they are controllers, they're console commands. They extract data from the request, pass it on into the use case that belongs inside the application core. On the other side, you have the driven adapters, which wrap around a library, an external tool, and implement whatever is needed by the core. Here, the dependencies go inwards. And this is important. This means that what's inside of the inside layers know nothing about the outside layers know about the inside layers. First layer, we have the application layer with the application services. These are the use cases. On this side as well, we have the command and handlers. These are the application services, if you can think of it that way. These are the use cases. On the other side, you have the event listeners, the events. The events run in the other side because they run after a use case has been executed. So at the end of executing a use case, you trigger an event. Event listeners catch the event and do some other logic. In the middle, we have the domain layer with the domain services and domain objects, the entities. Finally, we slice all our code base. Just like Uncle Bob said in Screaming Architecture, just like Eric Evans said in Domain-Driven Design, we have the bounded context. This is it. We slice pieces of our application into conceptually modules. The event listeners, the events in the event listeners are very important in this because that's the way that we can actually decouple the components because they still need to work together. They still need to execute the code from one component to another. So we can trigger an event from one component and listen to it in another component, and they are decoupled. Except that, well, where does the event live? If we trigger an event from component A and it is being listened by component B, and that event lives in component A, well, component B needs to know about that event as well. So in the end, it will know about the first component anyway. So where do we put that? Well, that's something that needs to be shared between components, so that belongs in a shared kernel. So we define a specific place to put this kind of code. Then both components, they are decoupled from each other, but they are coupled to this shared kernel, which is fine. So then we have all that I have been talking about on top, and then below it we have a shared kernel, which is shared for all the components. In the bottom we have the application, the programming languages, and somewhere in between we have what I call the Userland extensions to the language. For example, in PHP we have a datetime object, and it's fine, it's provided by the language, so we use it everywhere. Except if we suddenly need to add a method to that datetime object. Then what do? We need to create our own object. That's fine, we create it. But is there a reason to use it in a different way that we use the datetime object that is actually provided by the language? There is no reason for that, right? It's the same, conceptually the same thing. Just because it's written by us, it doesn't mean that it needs to have a different treatment. So we put it, that's the kind of code that I put in this layer. Because it's pretty much I treat it as part of the language. When I think about it, it's also, for example, with the UUIDs. So PHP doesn't provide for UUIDs, but UUIDs are pretty much agnostic about everything. Right? They could be provided by the language, they are not. But then why not use it just as if they were provided by the language? I'm sure there's a language that provides it. Of course, we need to make sure that it's under our control. If we use an external library, we need to do some kind of wrapper around it so that we can change the library if we need to at some point. But yeah. Okay, so we have all these ideas put together in our head. It's all very nice, theory and all, but then how do we actually put it into practice? So there's this idea of architecturally evident coding style. One of the things about it is to drop hints in the code. So if you have a repository class, you know what a repository is, you know how it should work, then just clearly identify it as a repository. Drop a hint in the code. Say, okay, this is a user's repository. You know exactly what it's supposed to do and how it should be treated. So yeah, just name it. Now, I don't say that we should do this for every class. For entities, for example, I don't do it. Value objects and enums, they're debatable as well. So yeah, don't go around postfixing everything. Just think about what makes sense for you and for your team. Another idea is to, it's from Simon Brown, it's pretty much saying the same thing as Uncle Bob said and as Eric Evans said as well. Just to make sure to identify the main components of your application. So how do we put this into practice? So we have our code, user interface, application core, infrastructure. We have our source folder. Well, we create a folder for each. User interface, core, and infrastructure folders. The driver adapters in the part of the user interface, how do we do this? Same thing, just create folders for each type of code that you have. You have a user interface folder, have APIs, okay, one folder for the APIs, then you have a folder for GraphQL API, for a REST API, so forth, so on. Also for websites. We have one application, but you can have several views into your application. One view is, for example, in a web shop, how the view that the consumers go to buy stuff. And then you have another view on your application, which is where the shop owners actually go and manage their web shop. Then on the side of the infrastructure, similarly, we have infrastructure folder. Okay, we create one folder for each tool that our application needs to use. Inside of those folders for the tools, then we create one folder for each vendor, because we can eventually have several vendors. I can imagine that if we have an application that sends out SMSs, and we are going to expand to another country, maybe the provider for the sending out SMSs is cheaper by using a different provider than what I'm using here. Then I have two different implementations. And in the end, it's just an adapter. It's pretty simple. And then all the code works the same way. So then we come to the core. And here, things are a bit more complicated. So first, we have a folder for all components. For example, a blog component. Inside each component, we have the application layer. And next to it, the domain layer. Each of them have their own folders. Then we have a folder for the ports. And then there's a port for each tool that we're going to use. And this ports folder is at the same level as the components folder, because they don't really belong in in any component in specific. So they're generic, they're being used by all the components. And then you have the shared kernel. And the shared kernel also, it belongs to the core, but it doesn't belong to one specific component. It's used by several components. So recap. So we have the first layer, have the user interface, the core, the components, the port, the infrastructures. We have the shared kernel also inside the core, outside of the components. And then we have the extensions to our own extensions to the language. And this should be completely outside of our project. I mean, it can be in our repository, but treat it as something that is outside of the project. And it eventually, you can extract it into its own repository. So we don't need to run the tests on them anymore. And we can even, at some point, maybe reuse it in another project, because they're basically agnostic of any domain. Now, this is all very nice, but we're only humans. So we have all these ideas, we know how to put it into practice. We have these rules, we talk about with our colleagues about all these rules that we want to put into practice, but we're going to do mistakes. So how do we prevent us and our colleagues from doing mistakes? There's this little tool in PHP called DEPTrack, created by Sensio Labs. I'm sure there's something like this in other languages as well. And what we do with this tool is we pretty much do tests to the structure of the code base. Same way as we run unit tests, we run these tests. So we create a YAML file, we configure there, we set there what are the layers that we have in our application. Then we create a rule set saying, okay, this layer depends on that layer, this layer depends on that layer, so forth, so on. And then we run it in the command line. It gives something like this. This is pretty much what comes out of a PHP unit or any unit testing framework as well. So we can put this in our CI. And in the end, yeah, if it breaks the build, it breaks the build. People have to fix it. Put things in the right place, do the right abstractions, so forth, so on. If you want to see this a bit more visually, then we can see it something like this. So clearly, control depends on services, on queries, on the repositories. In the other side, there's a repository depending on the controller, which obviously is wrong. In a bigger project, it looks something like this in the end. So we have, for example, if you look at the domain part here, a lot of arrows pointing at it. Everything depends on the domain. The domain is only depending on the shared kernel that is part of the domain as well, and on the language itself. Same thing then for the application. The application knows about ports, knows about the domain, knows about the shared kernel, but the infrastructure, but it does not know about the infrastructure, not about the user interface. Okay, so if you fell asleep in between my slides, this is the slide that you need to be awake. So I have 5 takeaways from this. First one is a code unit must have only one place to live. And this doesn't mean that we should magically know where a piece of code should be. It means that as we navigate through our code base, it should be easy to find. So if I'm thinking about a controller for something about users, okay, then we go into the source folder, okay, go into the user interface, yeah, go into the administration side of the website, then go into the user part of the code base, and then you'll find there some controller about the users. Make the architecture explicit. And by this, I don't mean that you should do exactly everything that I said. It means that you find a way with your colleagues to use some ideas that make sense to your project and that make sense to your colleagues as well. That everyone is in sync about these ideas. Everyone knows where each piece of code should actually go and what it means. In the end, whatever choices you make, you should always favor modularity and encapsulation because that's key. That's the basis of all the code that we build in the end. I like to think about, when I'm coding monoliths, I like to think about microservices because it helps me think about how we should decouple things. With microservices, there's, if you think about it, how should I decouple this if we had microservices? Then you know, okay, I would work here with events or whatever else. Then you try to transport those ideas into a monolith. And of course, you cannot transport everything, and you should not transport everything exactly like that. But it can give you ideas of how it should be decoupled. And finally, enforce the architecture, because we're just humans, so we're going to make mistakes. And if not our colleagues, ourselves, that's it. So that's all I have for today. You can get the slides there. Code sample in PHP as well. And you can check my blog. That's all.
We've got time for a few questions if anybody has them.
Oh, shit. Yeah.
Yeah. That was a very nice presentation. I have a question in my mind. If a team is following test-driven development, and suppose we come up like now we do DDD or domain-driven design. So test-driven development allows to evolve domain, like you write tests and then you're eventually you figure out your domains. You plan, you design your classes there.
Yeah.
But that's outside it. But how is it DDD? Like it's inside out. You have to think about domains first. Then both are like countering.
Yeah, I think it's different than it's unrelated to the testing. I mean, you should start always by your domain. Understand what you actually need to build, and if you do that, then you realize through much discussion, you realize what main cogwheels you have in your application. Okay, you have a building system, you have an account system, registration, it's part of users, so you put it all together. So you have these main cogwheels and just structure your code in that way. Decouple them as much as possible. Then the testing, well, yeah, you just need to do testing. That's it. I mean, I don't know. The testing as well should be isolated to those specific components. Yeah. Anything else?
So you used it as a workshop, I take it?
Yeah.
How is the onboarding going for new colleagues? Do they like drop the idea and are productive in the day, or can you elaborate?
Yeah, we always have some time with them to explain everything. So, yeah, and then we haven't had much problems. I think also because my managers try to only hire seniors. I think we have only one junior there. And then, yeah, it's everyone can help. So, but even us, the seniors, sometimes we lose track of it. and we end up making mistakes. That's why it's important to actually make sure that we test these kind of ideas, our code structure, just like we do unit testing. Yeah.
Yeah, I really like the idea of testing your architecture.
Yeah.
Cool. Yeah.
Have you also experimented with event sourcing in this type of architecture?
A little bit, yes. We said we have some kind of event sourcing part in our code base, but mostly we use a third party. So we have our own internal events happening, and there's one listener listening to whatever events are relevant to the BI people, and then it just transforms that internal event into something that the third-party application can actually store. And then they transform that into a database and transform that into nice screens for business people. We also have some event sourcing but it's a bit, it's not quite the typical event sourcing, but it's in our account we have some kind of something like money kind of thing, because each service pro, each plumber or whatever, they have a plafond that they can spend every month. So we do have some event sourcing there, but even then it's it's in its own module. It's completely separated from the rest of the code base.
In its own bounded context?
Yeah. As much. I mean, it's not perfect what we have, but we work on it. So.
We got time for one more question if it's snappy.
One more. One more two. One more three. Okay.